right, so we're talking about greatest common factor today. A common factor is a whole number that is a factor of two or more non-zero numbers. Remember our divisibility test the other day? If I had the numbers like 4, 6, and 8, what do they all share?
They're divisible by 4. No, they're divisible by 2.
They're divisible by 2. That would be a common factor, and that would actually be the greatest common factor. Okay, so we are going to be looking for the greatest common factor, but what if we looked at the numbers like 6 and 7? Do they share anything other than 1? No, because this is, what, 2 times 3? And that's just 1 times 7. When they only share a 1, the only thing in common is 1, the greatest common factor is 1, is called relatively prime. Okay? And they're going to ask you, is a number relatively prime? You're going to write yes or no. Okay? There are a couple different ways to get the greatest common factor. When you look at 4, 6, and 8, Sam said 2 is a common factor, right? That wasn't hard. You could do that by the list method. But when you look at numbers like 27, 18, 36, and 48, and let me read the problem that this came from. Okay. A high school asked for volunteers to help clean up local highways on one Saturday each month. The group of volunteers has 27 freshmen, 18 sophomores, 36 juniors, and 45 seniors. So that's the reason I wrote those numbers down. What is the greatest number of groups that can be formed if each group is to have the same number of each type of student? How many freshmen, sophomores, juniors, and seniors will be in this group, or in each group? Okay? So these are the number in each class. They're basically asking you, what's the greatest number of each you can have in the group? They're asking you to find the greatest common factor. Do you guys remember doing this when you were younger? You made lists. How many of you remember that when you did lists, you forgot some? I'm going to show you the easiest way to do it. Let's do prime factorization for each one of these, okay? So let's just do this real quick. 27, that breaks down into what?
9 and 3.
9 and 3. And then 9 is 3 times 3. So circle each one of those. 18 is 3 times 6. And then that's 2 times 3. Yes? 36. 6 times 6, which is then 2 times 3 and 2 times 3. Circle them. And 45, 5 times 9. That's prime, and that's 3 times 3. Are there any of the circled factors that are common in each one of the 4? Tessa?
3.
So what I do is I write down greatest common factor, GCF, equals, and then I mark out, they share a 3, share a 3, share a 3, share a 3, mark it out and write it down. Do they share anything else? Maria? Mark it out, mark it out, mark it out, mark it out, and write it down with a multiplication in the middle of them. Do they share anything else? What? Notice 18 and 36 both have a 2, but does 27 and 45? So that's not common to all of them. There's nothing else that they share. So what we do is we multiply them together and we get the greatest common factor of 9. And you want to know how you're right? Huh? Take 27 divided by 9 and you have 3 left over. Take 18 divided by 9, you have 36 divided by 9. 45 divided by 9. Do these four numbers share anything other than 1? So that's how you know you got the greatest common factor. Okay, so what we're going to do is number 1, find the greatest common factor between 54 and 81. Okay, so go ahead and do your factor trees, prime factorization. So here's our prime factorization for each one of them. Well, what do they share? Well, they share a 3. Mark it off, write it down. Put a times in there. They share another 3. Mark it off, write it down. And they share another 3. Mark it off, and write it down. Do they share anything else? No. So 3 times 3 is? 9. Times 3? 27 would be the greatest common factor. Well, 54 divided by 27 is 2, right? What's 81 divided by 27? 3, right? Do 2 and 3 share anything other than 1? That's how we know we have the greatest common factor. Do number 2. Okay, so they shared a 2, marked it off. They share a 3, write it down. Do they share anything else? No, so the greatest common factor is, please do not forget to multiply these back together. 12 divided by 6 is 2. 48 divided by 6. 66 divided by 6. Do 2, 8, and 11 share anything other than 1? No. 30 is 3 times 10, isn't it? That's 3 times, what, 2 times 5? 49 is 7 times 7. Do they share anything? No. So what is the greatest common factor? Christian?
Relatively prime.
It's 1, so yes, and they're going to ask you, is it relatively prime? Good, Christian. Those are relatively prime. So you have to say the greatest common factor is 1. So we do this the same way. Look at 16. Prime factorization, we know it's 4 times 4, isn't it? Which is 2 times 2 times 2 times 2. Is that right? X squared factors into x times x. And then you just have another y there. So 26 x squared y cubed factors into 2 times 13 times x times y times y times y. So to find the greatest common factor, we do it exactly the same way. Is there anything that they share number-wise? Sam?
They both have a 2.
So mark it out, write it down. Now look at the variables. This one has an x, this one has an x, so I write it down. But they both have another x, so mark it out, write it down. Then they have a y and a y, mark it out, write it down. They do not share anything else, so we multiply these all back together and we get 2x squared y is the greatest common factor. You do number 5. It's 40xy cubed and 24xy. Okay, so we have our prime factorization of 40xy cubed, 2 times 2 times 2 times 5 times x times y times y times y. 24xy is 2 times 2 times 2 times 3 times x times y. So the greatest common factor, Tessa Ortman, what do they share?
2.
Anything else?
2.
Anything else?
2.
Anything else?
X.
Anything else?
Y.
Anything else?
Nope.
So what's my greatest common factor?
8xy.
How many of you got 8xy? Okay, make sure you read the directions. They will say, find the greatest common factor and tell if the numbers are relatively prime.